Okay, here is a quick tutorial on how to draw Lewis dot structures that hopefully you remember from general chemistry or chemical principles, but if not, we'll go back through some of the steps that we would use to draw the Lewis dot structures. Now, Lewis dot structures basically show you a couple of things. They show you where all the electrons in the molecule are basically allocated. How many are in lone pairs, how many are in bonds, single, double, or triple bonds, and what atoms they're associated with. So there are some rules that I like to suggest people use to draw Lewis dot structures. So for instance, number one here, we're going to identify how the atoms are attached. Now, in the homework problems, and my general rule is I will give you how the atoms are attached. But at the moment, we never draw rings, and we can follow a couple of rules to help us get the core of the structure if it's not given to us. Number one, hydrogen and fluorine atoms always show up at the end of the molecule, and the central atom is usually the least electronegative, with the exceptions being when you have a halogen attached to an oxygen. That's one of the exceptions. But in all the problems that I'll do here in the next couple minutes, and also for the homework problems, I've given you the core structure. Then what I like to do is write the Lewis dots around each atom. So I'm going to give each atom the appropriate number of electron pairs or electrons that it has, depending on its group. And then what we do is then we begin to form single bonds by sharing single electrons from each atom. If your structure is an ion, you're going to add or subtract electrons, and you can take those from any atom. If it's a negative ion, you're going to add the appropriate number of electrons. If it's a positive ion, then you're going to take the appropriate number away. And then you take or give the appropriate numbers of electrons to give you the charge. And then you look at all the atoms. If there are any atoms that don't have completed octets, we then pair up the electrons to fill the octets, forming double or triple bonds. And what you have to remember is that there are some atoms that can never have expanded octets. There are some atoms that'll just share basically 2 electrons. The biggest example of that is hydrogen. And some elements can have expanded octets. The atoms that can have expanded octets are the ones that are row 3 or lower on the periodic table. So in particular, things like phosphorus, sulfur, and these halogens can all have expanded octets because they're row 3 or lower. Carbon, never an expanded octet. Oxygen and fluorine, oxygen, nitrogen, and fluorine the same. They will not form expanded octets. So you can never have more than 8 electrons around a carbon, nitrogen, oxygen, or fluorine. Okay. So the simple examples would be, how do you write the Lewis dot structure for something as simple as O2? I would take my 2 oxygens. I would go back to my periodic table and say the periodic table for oxygen. Oxygen is a group 6 element. That means it has 6 valence electrons. And so I would place 1, 2, 3, 4, 5, and 6 valence electrons around the oxygen. Over here I do the same thing. 1, 2, 3, 4, 5, and 6. Hopefully you remember that from general chemistry. Then I would take, and since this is oxygen, a neutral molecule, I don't have to add or subtract any electrons. Just simply take and form my oxygen-oxygen single bond. Is each oxygen have a completed octet? No. And so then I would just simply pair up these other unpaired electrons so that my final structure would then have each oxygen with sharing 8 electrons, and it would have an oxygen-oxygen double bond. Nitrogen, you would do the same thing. Have 2 nitrogen atoms. We've got 5 valence electrons around nitrogen, because if you look at the periodic table, we have it being in group 5, so it has 5 valence electrons. In this case, again, neutral molecule, I would go single bond, they don't have completed octets, double bond, still no completed octet, triple bond, and so now those nitrogens are sharing 6 electrons, and they have now a total of 8 electrons that they combine, own, and share. And C2H4, first, what's the core structure? Well, I would give you that, and I would say here's the core structure. My left, I have a carbon attached to a carbon, and then the carbon attached to the then each carbon is attached to 2 hydrogens. So I would give 1 valence electron to each hydrogen, and then I would give 4 valence electrons to each carbon. Now I form my single bonds by pairing up 1 electron from each atom, like so. Now the hydrogens are happy because they're sharing 2 electrons, and that's the most they can share. This carbon, though, is only sharing 2, 4, 6, 7, and so therefore it needs to share these those 2 unpaired electrons and form a carbon-carbon double bond. Okay. So very quickly, that's kind of the basics and the rules that you follow to write Lewis dot structures. Now, we did these 3 examples are neutral molecules, and so the question is there a way to do a molecule? Can we look at a structure that, for instance, might have a negative charge on it? So let's do that. Now, the example I'm going to give you is going to be one where there is more than one possible Lewis dot structure, meaning that there's resonance. But let's say that I gave you the structure for SCN minus. So if I gave you SCN minus, can we draw a legitimate Lewis dot structure for this, and how would I do that? This being now a negative ion. So the sulfur is attached to the carbon attached to the nitrogen. The carbon is the least electronegative of those elements, and so therefore it would be in the middle. And again, I would give you that. So how am I going to draw that Lewis dot structure? Well, I know sulfur has 6 valence electrons because it's in the group 6. It's right below oxygen. Carbon has 4 valence electrons, and nitrogen has 5 valence electrons. Now, I have a negative charge on my ion, so I need to add 1 electron to this molecule. And where can I add it? I'm going to actually add it anywhere, but I'm going to add it to the sulfur. If you want to be different, add it to the nitrogen. You'll get, well, you might get a different structure, but that's because this one has resonance structures. So let's just add it to the sulfur. Okay, so now I've got my negative 1 ion, so now I'm going to share unpaired electrons to form an SC single bond and a CN single bond. Now sulfur is okay because it has 8 electrons that it's sharing, so its valence is, its octet rule is filled. Carbon does not have a completed octet. And if I look at nitrogen, I got 1, 2, 3, 4, 5, 6, and so nitrogen isn't completed either. And so what if I take this pair of electrons and I form a double bond to that nitrogen? Is that going to fulfill the octet rule for the carbon? Well, let me just write that in here and then sort of clean this structure up. And let's see where we stand now. So carbon has 2, 4, 6, 7, not at a completed octet yet. Nitrogen is at 2, 4, 6, 7, so the final would be just simply to form that. And so now one of the 2 possible Lewis dot structures for SCN minus would look like this. Okay. Now, whenever we have a Lewis dot structure, we have to assign the formal charges to the atoms. And so if you want to assign the formal charges, you have to remember either the formula, or I'll show you very quickly And then in the lecture for Wednesday, I also go into this sort of a more holistic way of calculating formal charges. So the formula for calculating a charge on an atom in a Lewis dot structure is given by this formula, which basically says that you take the total number of electrons that are in the neutral atom and subtract from that 1/2 of the number that are in bonds, that 1/2 the number of bonding electrons, minus then the total number of unpaired electrons, and that'll give you the formal charge. And the rule with formal charges is that the formal charges have to add up. All formal charges on all the atoms have to add up to the total charge on the structure. So if you get a different sum of formal charges than you have on your structure, you're wrong. And somewhere along the line, either you miscalculated a formal charge or you've got the wrong structure. So if we go back to something like our nitrogen here, nitrogen has in its neutral atom 5 valence electrons. So if I want to calculate the formal charge on this nitrogen, I would have 5 minus 1/2 the total number of bonding electrons, which is 2, 4, 6 in this case for a triple bond, and then minus the total number of non-bonding electrons, which is 2. And so if I do that, I got 5 minus 3 minus 2, which means I have a formal charge of 0 for both of these atoms. Same thing would be true for oxygen. Oxygen has 6 valence electrons in a neutral oxygen, minus 1/2 of the number of bonding electrons, which is 4. So every bond counts as 2 bonding electrons, minus the total number of non-bonding electrons, which is another 4. So I've got 6 minus 2 minus 4, which gives me a formal charge of 0 for these 2 oxygens. For carbon, for this molecule, what are its formal charges? Well, hydrogen has 1 valence electron minus 1/2 of 2, 1 minus 1 because there's no lone pairs. Carbon, there's no lone pairs, so we would have 4 minus 1/2 of 8, so 4 minus 4 is 0. So in this structure, all the atoms have 0 formal charge. Now, what about SCN minus? I know that if I have SCN minus, I'm going to have the atoms add up to a total charge of -1. The formal charges are going to have to add up to that. So the question is, does one atom just have a -1 charge, or is there a combination? So if you want, take a minute, shut the tape off, see if you can calculate the formal charges for these 3 atoms. Doing it for sulfur, sulfur would have 6 valence electrons in a neutral molecule, minus 1/2 of 2 bonding electrons, minus 6 lone pair or non-bonding electrons. So 6 minus 1 minus 6 gives me the sulfur having a -1 formal charge. How about the carbon? Well, in this case, carbon has 4 valence electrons in the neutral atom, minus 1/2 of 8 bonding electrons because it's got triple bond and a single bond, and then it has no lone pairs, and so 4 minus 0 equals 0 formal charge. How about this nitrogen over here? That nitrogen has 5 valence electrons in the neutral atom, minus 1/2 the total number of bonding electrons, which is 6 because it's a triple bond, minus 2 non-bonding electrons. So we've got 5 minus 3 minus 2, and so that nitrogen has a 0 formal charge. So carbon, 0 formal charge, nitrogen, 0 formal charge, sulfur, -1, and so therefore the overall charge is -1, and so we got a legitimate structure. And we can take a more sort of holistic approach to drawing to calculating formal charge if and the way we can sometimes think about this is how many electrons did the atom bring to the structure when it was a neutral atom, and how many electrons does it now own? And so the difference then, if it picked up an electron, it's got a -1 charge. If it lost an electron, it's got a +1 charge. So sort of a more holistic approach, or just a non-mathematical one, would be simply to look at this and say, okay, how many valence electrons did sulfur bring to this structure? And the answer was 6. How many valence how many electrons does this sulfur now own in its structure? Well, if the sulfur and the carbon were to split apart, each atom would get 1 electron, so technically it owns 1 of the 2 electrons in this bond. And so sulfur came with 6, and it now owns 7 electrons, which means it picked up 1 valence electron, so it has a -1 charge. For carbon, if we apply that method, carbon had 4, it came with 4, it now owns 1/2 of every bond, so it owns 1, 2, 3, 4. So it came with 4, it has 4, it's got a 0 formal charge. How about the nitrogen? Well, for the nitrogen, it came with 5. It now owns these 2 outright, and it owns 1/2 of the 2 electrons in each bond. So it owns 1, 2, 3, 4, 5. Came with 5, now owns 5, and it has a 0 formal charge. Okay, so that's sort of a quick tutorial on how to draw Lewis dot structures and calculate formal charges. And so now you can do your homework, try some of the homework problems, which are online. There'll be a narrated answer key for that, so you can kind of see me go through this process again. And then on Wednesday, we'll expand this to talk about what happens when your Lewis dot structures, when your molecule can have more than one valid Lewis dot structure, which means that it has resonance structures. Okay, this doesn't quite make sense. Send me an email, come see me, but hopefully this will get you started.